Today we're going to be talking about paragraph proofs. But before we even get into this type of proof, let's go over what exactly a geometric proof is. A geometric proof involves writing reasoned, logical explanations that use definitions, axioms, postulates, and previously proved theorems to arrive at a conclusion about a geometric statement. So for example, if you have a shape, you can't just say these two sides are equal or congruent because I say they are. You need to back it up with the properties we've learned, definitions, any of the postulates, and the theorems. Okay? So specifically today we're going to be talking about a paragraph proof. And a paragraph proof is written as sentences in a paragraph. Um, so as we go into geometry a little bit more, you're going to notice there are two other types of proofs that are more mathematical looking. This is going to look more like an actual just paragraph written with a bunch of math terms in it. Okay? So what we're going to do right now is we are actually going to go over what a proof looks like. Okay? So your first step is you're going to study what is given, what you have to prove, and the diagram that you're given. Okay, so in this case the diagram would be this. And you have to write a paragraph proof about this. So in every proof you're going to get a picture or a diagram. You're going to get something that is given, okay? And then you're also going to give something that you need to prove to be correct. And you're going to need to do that in a series of different ways. One of the most important things about proofs is you cannot assume that something is already stated or that it should just be implied. You need to be very specific, okay? So just to break it down, so this is what you know to be true, and this is what you show, okay? So if you take your diagram and you start to think about it, all right, we can go through and we can actually write a paragraph using some of the theorems you learned yesterday. We learned a lot about the different vertical angle theorems, excuse me, um, that you can use in order to solve this. Right away you know, okay, we're working with vertical angles, okay? And the vertical angles are angle 1 and angle 2, okay? Now, knowing the definition of vertical angles, we could probably safely assume that angle 1 is congruent to angle 2, but we need to prove that correct, okay? And it's going to seem very roundabout, but I promise it'll make more sense as we go, okay? So the first thing is I'm just going to show you what the answer to this particular paragraph proof would look like. So by the angle addition postulate, okay, which we learned about, we can say that measurement of angle 1 plus the measurement of angle 3 equals 180. So we're talking about this angle and this angle equal 180 degrees. And we can see that because this is a straight line and they are collinear angles, okay? We also know that angle 2 and angle 3 are also 180 degrees. So by substitution, okay, we can actually create this equation right here. So we know that measurement of angle 1 plus the measurement of angle 3, which is what was up here, okay, and the measurement of angle 2 plus the measurement of angle 3 both equal 180 degrees, so they actually equal themselves. Now by subtracting measurement of angle 3 out of both of these, we actually get that measurement of angle 1 equals the measurement of angle 2, or that angle 1 is congruent to angle 2. Alright, I know it seems very confusing. Alright, we're going to do one more example, and then it should make more sense. So here's our example. We have complete the proof by filling in the blanks. And we're given that angle FED and DED FEW are complementary, and we want to prove that those two are right angles. Now we're going to just fill into the proof that is given here. So it says, by the definition of complementary angles, the measurement of FED and the measurement of angle DEW is going to equal, because they're complementary, 90 degrees. Okay? And the measurement of FED plus the measurement of DEW equals the measurement of FEW by the angle addition postulate. Okay? Because these two are added together, they create a bigger angle, which is what the angle addition postulate states. And then 90 equals the measurement of angle FEW by a certain property of equality. Alright, so we're taking these two ideas and we're combining them, and that's the subtraction property of equality. Okay? Then the angle FEW, sorry, typo, is a right angle because the definition of a right angle. And the right angle definition of a right angle states that it's 90 degrees. So by that definition, we can prove that angle FEW is in fact a right angle. Alright, so tomorrow we're going to be working a lot on these proofs and with these theorems. So please let me know if you have any questions.